On this video, we're going to work some more practice problems on indefinite integrals from section 6.2. So here we have to start with the integral of sine x plus cosecant squared x plus cosecant x cotangent x. These are ones that we have to know from memory. So the function whose derivative is sine x is going to be a negative cosine x, because remember the derivative of cosine is a negative sign. The derivative of cosecant squared is going to be a negative cotangent x, because the derivative of cotangent is negative cosecant squared. And the derivative of cosecant cotangent will be a negative cosecant x, because the derivative of cosecant is negative cosecant cotangent. And then we're going to get our plus c, the constant of integration. The next one, the trick to this is to split this up and call this x to the fourth over x squared minus 2x cubed over x squared plus 5x squared over x squared dx. And then we can simplify that further. So x to the fourth over x squared is just x squared, and then we'll get a minus 2x and plus 5 dx. And then we can integrate each of these. So we'll get a 1/3 x cubed, and then we'll get a minus, and then we'll have a 1/2 x squared, and the 1/2 will cancel with the 2 and make that just a minus x squared, and then a plus 5x and plus c. And there's our antiderivative. The next one, we're going to have to use our power rules. So I'm going to rewrite this first as being x to the 3/5, and then that's going to be minus, and that'll be an x to the negative 1/3. Since the cube root is in the denominator, I'm going to leave that as a 4. I'm going to think of it as a 4 times 1 over x dx. So then we can use our power rule for the first two. So adding 1 to the 3/5 is going to make that be 8/5, and then we need its reciprocal in front. Adding 1 to the negative 1/3 will make that 2/3, and we need its reciprocal 3/2 in front. And then we'll get a 4 times. Now this is one that doesn't fit the power rule. Remember, the integral of 1 over x is the natural log of the absolute value of x plus c, and it becomes our indefinite integral. The trick to the second one is to multiply that out first. So we're going to get the first one squared, which is 16x squared. Twice the product will be a minus 24x, and plus the second one squared is going to be a plus 9. Integrating these, we'll get x to the third over 3, so that's going to be 16 thirds x to the third. We'll get an x squared over 2, which will cancel with the 24 to make that a minus 12x, and then we'll get a 9x and our constant of integration. Similar to the last one we did, we're going to have to multiply this out. So the first one squared is going to be x to the fourth. Now the product, twice the product, when you multiply an x squared times a negative 1 over x squared, those will cancel and just be negative 1. Twice that product will be times 2. We'll make that just be a minus 2. Then we're going to get the second term squared, so that negative, I bumped it with my hand again, the negative 1 over x squared squared, to bring my pen back up, is going to be a 1 over x to the fourth. So I'm going to write that as an x to the negative 4 dx. Now when we integrate that, we'll add 1 to the exponent, multiply by the reciprocal of the new exponent. The integral of a constant is the constant times x. Adding 1 to the negative 4 makes that a negative 3. its reciprocal will be a negative 1/3, and then we'll get our constant of integration. It's kind of a tricky one. Now the next one, we have these different integrals. The integral of e to the x is our favorite integral. It's just e to the x. The integral of 5 to the x is far from our favorite. It's going to be that same 5 to the x divided by the natural log of 5, and then we'll get our constant of integration. And the next one, find f of x if f prime of x is 1 over x and f of e is equal to 3. So we can integrate both sides here, and that will give us the integral of f prime is our f of x. The integral of 1 over x, remember, is our natural log of x plus c. We're going to plug in e for the x and 3 for the y and solve for our constant c. So that's going to be 3 equals natural log of the absolute value of e plus c. Now the natural log of e is just 1, and so that is going to make c be 2, and will then make our function be f of x equals the natural log of the absolute value of x plus 2. And the next one is kind of like that, but we go a little even further. So this is going back to our particle motion idea. So the acceleration is negative 32. That's what it is on Earth, negative 32 feet per second squared. We know that the acceleration is the derivative of velocity, or also known as the second derivative of position. So we're going to work our way back up to find position eventually. So first, if we know the initial velocity, the velocity at time 0 is 10 feet per second, can we find the velocity v of t? So we'll start by integrating here, and the integral of v prime will be v of t. The integral of negative 32 is negative 32t, because we're integrating with respect to t, plus c, the constant of integration. We're going to plug in 0 for t and 10 for v and solve for the c. So we'll get negative 32 times 0 plus c. So that tells us that c is 10. And so v of t is going to now be negative 32t plus 10. Now from there, part B, we can use the fact that the initial condition, s of 0 is 13, to find our position function. So we will now integrate both sides here, and the integral of v of t, which is s prime, so v of t, remember, is the first derivative of position. So integrating that will give us s of t, and integrating the 32t, integrating t is going to be t squared over 2, so that's going to be 16t squared plus 10t plus our constant of integration. We'll plug in 13 for the position when the time is 0, and that will tell us that c is 13, and that means that our position function is going to be negative 16t squared plus 10t plus 13. Okay, very good.